since the bouncy ball lab is already due, but several people haven't done it yet, I'm just giving a moment to talk about it and ask me, is there any part of that that you're not understanding? Like, I don't know what to do in the procedure section. I don't get how to do the summation, or you want to ask any questions? Now is an okay time. Yes?
In the performance section, we had to write the sigma notation at the end. We were supposed to do the sigma notation for just like normal word or to the doubles.
Yeah, so you can't do it with the doubles in it. There's no way to put something here so that it'll make it, when you put in 1 to infinity, there's no way to make it so that when you put in 1 and you put in 2 that you'll get the same exact number. That doesn't exist, okay? So you can simplify your series down to 100, and then let's say it was, I'll keep mine super simple, 50, 25, 12.5. You can act like there's no bounces in order to write this. Otherwise, there's no way to write it. Okay? All right. But at the end, when I actually ask you how far did the ball travel, you better factor in that it was bouncing. Okay. Next question. Is that a question?
In the sigma notation, how does like the sigma letter affect like the different terms in the sequence?
This sigma letter is just signifying that when you stick in 1 and you get an answer, so like let me do this one. Okay, so 2 times 1 is 2 plus 5 is 7 was my first term. And then I do the next one, I stick in 2 because I'm on my way to this one, right? So I'm going to stick in 2 now, and 2 times 2 is 4 plus 5 is 9. And then, gee, look, it seems like it went up 2. And then I'm just going to put in a third one. I put in 3, and 3 times 2 is 6 plus 5 is 11. Glad you're here. Okay, then dot, dot, dot. Now I can look at this and say, oh, it's arithmetic. I can use the arithmetic formulas. And this summation is telling you, I want you to add them all up. It's a term generator, but that formula there does not add up all the terms, does it? No, it just generates the terms. And then you have to know the other formula you would use to actually add them all up. So this letter is just a symbol that says, hey, I want you to sum them. That's considered a summation symbol. Okay? And then you'd have to use a different formula to actually sum them. But it's like saying, this problem is about adding up all the terms. That's what the E stands for. It's not an E, it's actually a sigma, and it's a Greek letter. So it's your sign that we want to sum these all up. It's a little bit like, you know, in those formulas where it said S sub infinity, the S meant sum, and it was kind of like saying that, except it's different because this is trying to tell you how to generate all the terms. That little formula there generates each of the terms. Okay, any other questions about the lab? Just wanted to give a minute or two to ask lab questions. Okay, then let's move on. Now, I think the hardest thing on the test that you are about to take, not today, but next week on Wednesday. Monday you have off because it's Memorial, and then Tuesday we'll do review, and then Wednesday's the test. I think the hardest thing is probably this. Would you please find me the third term in this binomial expansion? There would have been 16 blanks. That'd be a little painful. So we'd say that's crazy. But find me the third term in this binomial expansion. Pause for a sec. Will you find that? Get started with the pattern. So you put out the lines, okay? Now what?
So I started out by doing 2x 13 to the second, and then
2x to the 15 here, 2x to the 14 there, 2x to the 13. Okay, I'm with you.
and then the 3 because it would be easier.
So negative 3 to the 0, -3 to the 1 here, and then -3 to the 2nd. You guys with her so far? Okay, good. Now we need those 1, 3, 3, 1 kind of numbers from the Pascal's table, but Pascal's triangle is going to take you a long time to get to the one that has 16 numbers in it. Okay, so instead, did you do something, see something? Did you remember how to do that?
Yeah, 15C, I forgot, was it,
You start with 0 here. 15C0 for this one. 15C1 for this one, so...
15C2.
Yep. Now, that might take you a minute to figure out. If you had a calculator, would it help? Well, maybe. You still have to know what C means. So you go 15 factorial over. Do you remember what to do here? To put these on the bottom? That's pretty easy to go 15 factorial on the top, but you know what to put on the bottom. Just a reminder, I see a couple cell phones out on desks. If you could put those away, please, at this time. Also, if you have headphones on, take them out. Yes. 15, what do you do with the 15 to figure out something to put on the bottom?
You subtract it by the 2,
Yep, so 15 minus 2?
and then multiply that by another b.
13 factorial with an extra
2 factorial.
2 factorial. You are correct, sir. So then really, you don't need to do anything complicated on your calculator. You can just go, well, this would be 15, 14, 13, 12, dot, 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 over 13, 12, dot, 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 and then an extra 2 factorial here. And this 13, 12, 11, 10, 9, 8, 7, 6, 5, 13, 2, 1 cancels this 13, etc. And now that and that can cancel. 14 divided by 2 times 1 is 14 divided by 2, which is 7. 7 times 15, 15 times 7, 7 times 5 is 35. 7 times 1 is 7 plus 3 is 10. 105, yay. 105 goes right there. Then, final answer, that's really a 9 times the 105 times the 2 to the 13th. Holy smokes. I would have been okay with you writing your answer with this way before you used the calculator. 9 times 105 times 2 to the 13th. Everybody forgets the 2. They see the x to the 13, but they forget that the 2 is also to the 13. And then times x to the 13th. So this part is considered the coefficient of it. And yeah, you could use a calculator on the test. And even if it was a really big number, you could write down that really big number right there. In case your calculator ever says this, what does that mean? That comes up as your answer. What does it mean? Well, it's scientific notation. And so 1.8 times 10 to the 7th is what that means. And that's 1, 8, and then you got 1, 2, 3, 4, a whole bunch of zeros after it. Okay, so it's a really big number. So if you see that come up in your calculator, you may not write that on the test. You have to know what that means. And that would mean a 1.8, move the decimal over 7 spots, means really in this case, add 6 zeros, and there we go. Comma, comma, 18 million, for example. This is not the right answer to our question. I'm just trying to show you an example of how your calculator often gives you really big, strange-looking numbers. That was the answer to our question. Any questions? Okay. Then we are going to pause for a minute. Okay, so what else is on this test? Well, this was, before we got into these binomials, there was a bunch of terms on those, right? Then there was other things that had terms. So let's talk about some of those. Actually, I apologize. We're going to instead go to page 2, and that's more about the bouncy ball lab, which, a reminder for those that just walked in late here, it's already due, it's past due. You need to get that in sooner. There will be a significant late penalty if it comes in after we've graded it. Okay. I'd like you to try these two, and I'm going to pause for a minute. And then eventually we will get back to what I was saying. But I do want to follow the notes today. I think everybody gets this part by now. X squared is to the 8th. X squared is to the 7th. X squared is to the 6th. To the 5th. X squared is to the 4th. That part's not too hard. The other part, the 3, that's not too hard. This part here is 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4th. And that's not that hard. So what's hard about it? Max, the last part's hard. How do I do it? It's the coefficient in front of all of that. Is it 8? Choose, well, gotta be careful here. What do we start with here? 8, choose 0, choose 1, choose 2, choose 3, and choose 4. If you can figure out 8, choose 4, you'll have it. I'll pause for a second. How do you do that 8, choose 4 thing?
So you put it like the 8, the expected point on top, which is 8 times 7 times 6 times 5.
Yep, it's called 8 factorial. I agree, sounds good. And then?
And then you do 4 on the bottom, or you do 4 on the bottom.
Because it was 8 minus 4 gives you 4 factorial. And then?
And you do the extra 4.
The extra one of those. Nice. Simplify it for me and just tell me at the end, what do you think the answer was? 70? 70?
Oh, yeah.
Can anybody verify 70? Ooh, a lot of people. Good. So if that's 70, and this one's 3 to the 4th, which is some other really big number. Got that, actually?
81.
Nice. Did you ever do 70 times 81?
No.
Okay, do it. Take a second, you can finish the deal. You got a calculator on that thing. 5, 6, 7, 0. X to the pressure. Yes. There's your term. Raise your hand if you had that one right. Cool. And the other one. The x to the 6th term from this. Well, then I know that I'd have to do it out quite a ways because 2x to the 14th would be here. And I got to go to where the x to the 6th would be. So 13th, 12th, 11th, 10th, 9th, 8th, 7th, 6th. Ooh, that one. That one right there is the term that I need. Okay? And that one had 2x to the 6th. And then I got this 1/2 to deal with. Well, that'd be 1/2 to the 0 here. 1/2 to the 1, 2, 3, 4, 5, 6, 7, 8. 1/2 to the 8th. And last but not least, we need that thing in front, which is, let me think, something see something. And it always starts with this number, so 14C, and then this one would have been 0. So 1, 2, 3, 4, 5, 6, 7, 8. 14, choose 8. 2x to the 6th, 1/2 to the 8th. That's gross. I'm going to say anybody with a calculator would be able to finish this. Let's just leave it as its parts. On the test, you would have to finish it. Do you guys agree with that as a starting place for the answer? Okay. All right. Then let's move on. This figure appeared at the front of a book that I cannot pronounce, written in China in 1303. Does that look familiar at all? Looks a little bit like that triangle we were just doing, does that look like a kind of could be a 1, 1, 1, 1, 2, 1, 1, 3, 3, 1? So then the question becomes, was Pascal before that? If this was written in 1303? Don't know, being honest. I don't know if Pascal wrote his triangle first. So it really kind of depends on like who gets the press. The Wright brothers are a lot of times given credit for the first flying machine, but there's a lot of different ways to define that. There were people who jumped off of cliffs with things, and that's different than taking off a flat surface. You know, jumping off a cliff with feathered arms doesn't really work so well on the whole flight thing, but you kind of flying, maybe you go a few feet. And the point is that some of these things are left up into interpretation. And so Pascal's triangle might not have been invented by Pascal, but maybe he figured out some cool patterns that other people didn't. Maybe he just published it in one place that got more press than in China, because maybe this was locked away in a vault in China for a long time and nobody else saw it. So who knows? All right. Oh, 60 and 62 is when he died. So I'm pretty confident, when he was born in 1623, so we can be pretty confident that that other Pascal's triangle that was done in 1300s was a long time before this. So again, I'm not a historian. I can't tell you exactly who deserves credit for what, but it's not like triangles were brand new. But this pattern is kind of cool. I want you to take a few minutes, and this is just for fun, and see if you can find 5 patterns. I'm going to give you one obvious one. There's ones all the way down the outside. That's a pattern. Second pattern. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13. And you could obviously keep going with this thing. So my question is, can you find me 3 more patterns that are happening there? Like, oh, here's what's happening in this row. Or, when I add them all up, this cool thing happens. Take a minute and try to find some patterns. I'm going to pause for a second. This is just for you to think about, and then after, I'll have you share them, any pattern that you found with the class. I bet you some people will find interesting ones that other people will totally miss. So one of the patterns that kids notice is that when you added these up, this was 1, this was 2 for this row, this was 4 for this row, this was 8 for this row, this is 16, and that makes it kind of a cool pattern because when you add them all up, you get a sequence where the numbers get squared each time. You know, 2 squared gives you 4, 4 squared gives you, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, etc. Okay, and now somebody just found these Fibonacci, and I'm going to see if I can show everybody where the Fibonacci was. 1, 1. So there's 1 there. 1, 1 is the next.
Just right to the bottom to the left.
Okay, the first one was here. Where's the 1, 1? Just these 2?
No, like right there. It's just 1, 1. It starts here, then it goes here.
How about this? I'd like you to do it with circling. Come up here and circle the numbers. We all see the 1. That's obvious. Just circle the 1, 1. Just circle each of them separately. Just use your finger.
The first one is there, and then the second one's right there.
Okay.
Then it goes to 2, which is right there.
1, 1. Okay.
Then it goes to, what is third? Then it goes to 3.
That makes 3. And then
5 is right there.
those make 5. Interesting.
And then, 3, 4.
And 7 and 1 makes 8. Oh, interesting.
Go 1, 6, 5, 1.
1, 6, 5, and 1 makes 7, and 5 is 12, plus 1 is 13. Those are adding up to Fibonacci numbers. I have never seen that before. So basically, he's just adding them up and he's never skipping any. And he's just kind of going, so then the next one theoretically should be like this 4 and this 10 and this 6 and then maybe this 1 and this 1. 21, no, 22. Is that one of the Fibonacci numbers? Anyway, I think it works. So that's really cool. All right, anybody else see a pattern? Yes?
I looked into it and, adding up, like, the grand total of each of the lines.
Grand total of each row. 1, and then plus that row makes 3, plus that row makes 4, 5, 6, 7, plus this row makes,
It makes 15, and it's, in that line, it's just one less of what the next line is when you just put the row together. So say, like the next row below that, if you just added the line together, it would be 16. So 15 is just one less of that.
oh, so the total of all the preceding ones, so you're saying this row right here adds 16 to it, making a total of 21?
No, I mean, like,
I get what you're saying. I do get what you're saying. I think you're saying that all of these added together is one less than all of these added together.
yeah.
So 21 is, you just have to add one more to that and you will get this. So we should be able to predict the next one. Should be we'd add one more to it, which makes 22, and then add 22 to 21, and it should be 43 grand total, which I think it is.
I think the one below is
Did I do it? Was I off?
I think 13 plus 16 is.
10, 20, 32. 32 in this row. And I think your theory is that all of these together should add up to 31. And this row is 32. Okay, that's a pattern. All right. I don't want to bore you to death with all the patterns. There's a lot. Does anybody else want to add one quick? Did you see another pattern that people didn't? Okay. I'm surprised nobody figured out a pattern in here. Just look at 1, 3, 6, 10, 15. See anything going on there? Patrick?
You like add one to what you added the last time. So you add 2 to the first one. And
So we add 2 here, add 3, add 4, add 5, add 6, add 7, add 8. You're exactly right. Nice job. I'm surprised nobody found a pattern in this. I'll highlight them in blue. There's like patterns everywhere in this thing. That's what makes this cool, is not just that it's a triangle of numbers. It's that there's so many patterns built into it. Anybody see the pattern with 1, 4, 10, 20, 35? All right. Got to leave some things to your imagination and you can play with it. Find more. All right. So there's a nice one if you want to mess with this during your really boring whatever class later today. Find some more patterns. Come back and show me tomorrow. All right. Here are some of them. The sum of the rows. If you like, this is the one that Kira was talking about. The sum of the rows in any row is equal to 2 to the n. That's the way they kind of summed it up. It's 2 to the power of. So this is the first row is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and that's the sum of the rows. Nice catch on that one. And then this is just them coloring in different patterns just to make it look pretty. That is a fractal, which also looks kind of similar. A fractal is basically the same pattern, this right here. being repeated over and over and over in a certain pattern. So it's a pattern of patterns. This one we already talked about. Square numbers. Square numbers? Yeah, there's such a thing as square numbers. You can look it up if you want. All right, we need to move on. And now, this is just another interesting pattern about circles and how many points you can put on the circle, and then how many triangles you can end up drawing, and with that number of points on the circle. And anyway, there's a lot of patterns in math, and that's enough of that. So here are some homework problems for you to practice. And some of these are pretty gross. They get like super intense. I don't need you to go super, super intense. This is just too hard. Like, it says it would take you 6 minutes. I think it would take you more like 30 minutes. And I don't think it's worth it. So just telling you, probably don't need to do that one. I would try this one for sure. You need to be able to be good at these. And this one says, the one that's got an x squared on it, yeah, I think that's the kind you're going to have to know for the test, so maybe you should do that one. The term independent of x, that really just means the constant. So that's kind of easy. It's the last number. Well, wait, they moved the constant to the front, though, sneaky devils. All right. And this is a challenge, so you do not have to do that. Of course, it's fun if you would like. And this page is just, again, I think it's going beyond what we would have to do on the test. So I'm saying you can skip those. All right, that's all I have for you for the video for today.